Hello, hello. Good morning. Gentlemen, good morning. How are you?
Hi, Richard. Cooper, this
Yeah.
is Kim, our new guy. You have corresponded on email.
Okay.
Yo.
Fine.
All right. Richard, we'll leave it to you and or maybe whoever wants to start first, Cooper or Richard. Cooper, you have to leave in 25 minutes.
Oh, yeah.
Oh, Richard, please go ahead.
Okay.
Yeah.
Richard.
Okay. 5% teams. Sorry, this might be might work, might not work. I've never seen that button before. Can you see fine?
Okay. Yeah, yeah. Yeah.
Okay. It's important that while I give this presentation, it's a little bit dry. It would be good if you ask questions as I go along. Anything's not clear, please ask.
Okay.
I guess the first misconception I probably need to allay is Mr. Puang. I'm based in Singapore, not UK.
Oh, yeah.
So if you need any soil samples testing, then send to Singapore, and that's very simple for me to do.
Yeah, thank you.
No problem. Okay. Just a little bit about my background. That's become 39 years in the tunneling industry now. I'm a mining engineer. I've been 27 years in Singapore. What's important? So, okay. From your emails, I hope this doesn't sound insulting. It's not meant to, but it sounded like didn't really have a very good idea on what's the difference between EPB and slurry machines.
Yeah, but I just know a little bit. Still want to hear more from you. Yeah.
Yeah, because I know that in Vietnam there's only ever been EPBs to my knowledge. I've never known any slurry machines. There may have been slurry machines that have been used for pipe jacking, but I'm not aware of them.
Yeah.
So there are lots of different types of tunnel boring machines. Earth pressure balance machine, everyone calls them EPBMs. You've got open face machines where the front of the machine isn't pressurized at all. You've got slurry machines where you use a bentonite slurry to create pressure on the front of the machine.
Excuse me, Mr. Skulkin. I just want to report
Certainly
your
don't call me Mr.
presentation.
Spilkins.
Call
Don't call me
Richard.
Mr. Spilkins. Just call me Richard.
Richard.
Drop the
Yeah.
Mister. Drop the Mister. I'm
Yep.
not that formal.
Yep. I would like to record all your lecture. Is that okay for you? Just we might forget the information you said, so I would like to record the meeting.
Record it. Okay. I think no problem.
Yep.
Well,
Thanks very much.
I've attached the presentations already. If you've not noticed.
Yep. So I'm gonna start the recording to make sure that we.
You remember everything. Okay.
Yep. Thanks so much.
I think Mr. Ann has probably got the same presentation about 3 times recorded over the years. But, yeah, okay. Hard rock machines where you don't, you can have either hard rock machines that have no face pressure, or you can have hard rock machines that have face pressure. And the truth is that you have, with all of these machines, you have a combination that you can have as well. So even though I've listed 5 types of TBMs there, you can mix and match between all 5 of those to make different kinds of tunnel boring machines, but that's basically it for now. Tell me, what do you see? Do you see just a small frame, or do you see a big picture? Because I pushed on a button and it makes it seem like it's quite small. Do you see this presentation big screen or not?
I'm seeing the big screen. A brief introduction to EPB machines.
Oh, you see a big screen. Okay.
Only the words. Yep. No picture, no photos.
Okay. Mhm. Can you see a video that I just put up? Can you see the video?
No, I'm just seeing a
No.
short video.
Yeah,
Kelsey
okay.
Robbins.
Stop.
Only that. Oh, it's end.
You have to be patient with me. Sorry. Share.
You want me to share the video, Richard?
No,
The video.
it's okay. I'm there now. I think I'm there now. Can you see it now?
Yep. Current node, something like that.
I see. I saw your computer, Richard.
Yeah, okay. I've attached this video as well if you want to see it. You need to see it. I'll put it full screen. Sorry to show a video. It smacks of being lazy, but the video can say it better than I can say it.
Knecht AG specializes in highly complex tunneling projects made to customer specification. Therefore, the machine is specifically designed and manufactured to cope with the prevailing geological and hydrological conditions. This ensures maximum efficiency, environmental compatibility, and safety when the tunneling project is on its way. Our film shows the structure of two of the most important types of machines made by Herrenknecht AG and how they work. The liquid-supported mix shield offers the best solution for successful tunneling in loose soils of all kinds and in heterogeneous geological conditions and cohesive formations. Even high groundwater levels can be safely handled using this method. The EPB shield is the first choice in homogeneous cohesive soils. The liquid-supported mix shield, shown here, consists of a cutting wheel with a center-free ring drive and special tool arrangement, the excavation chamber, the submerged wall, open at the bottom, the pressure wall, and the face support plates. The stone crusher. The feed line, for bentonite, the slurry line for soil bentonite mixture, and the compressed air line. The thrust cylinders to provide the thrust force, colored yellow, cylinders for the axial displacement of the cutting wheel for changing tools, colored green, as well as articulation cylinders for driving curves. Compressed air locks for access to the excavation chamber. And the erector for installing the segmental lining. All the jobs, from excavating the soil to installing the lining, are carried out under the protection of the shield. In the case of the liquid-supported mix shield, a bentonite suspension acts as a supporting and transporting medium. The suspension is fed into the annulus behind the excavation chamber via a feed line. Here, a mixture of the bentonite suspension and the excavated soil is created, which is pumped into a separation plant via a slurry line. There, the bentonite is recovered and can be immediately pumped back to the excavation chamber. The stability of the face is ensured by a filter cake placed ahead of it formed by the bentonite suspension under slight overpressure. A compressed air chamber behind the submerged wall makes it possible to precisely regulate the pressure and thus guarantees the stability of the face even under difficult conditions. An EPB shield consists of the widely closed cutting wheel with special tool arrangement and a center-free ring drive. A pressure wall with stators which form the excavation chamber together with the cutting wheel. A screw conveyor and a conveyor belt to transport muck. Thrust cylinders and articulation cylinders for inclining the tail skin when driving curves. A compressed airlock. And the erector. In contrast to the bentonite shield, in the case of the EPB shield, the excavated soil itself acts as a supporting medium. To be able to fulfill this function, it must first be turned into a plastified consistency. Depending on the local conditions, this is done by the controlled injection of conditioning agents, such as foam. This makes it possible to reduce the drive torque and cut down wear at the same time. The foam is injected into the soil ahead, via nozzles installed on the cutting wheel. Once the soil has been prepared in this way, it is no problem to transport it from the excavation chamber via a screw conveyor or onto a conveyor belt. From here, it will be further transported via rail or lorry. In the case of the EPB shield, the pressure for supporting the shield is controlled by the coordinated control of advancement speed and the screw speed. The excavation chamber will be filled to ensure adequate support of the face at all times and to be able to react correspondingly to pressures from the earth or groundwater.
Sorry, I'm having a little stupid. Okay, so that's the basics of a slurry EPB machine. Get back to the presentation. I don't know why my computer's so slow, sorry. Okay, This is an EPB machine. I'm only going to talk particularly about EPB machines because, like I say, you don't really have slurry machines in Vietnam, although I'll briefly touch on the differences. An EPB machine has a rotating cutter head. The soil comes through the front of the machine and into this chamber. So this chamber's full of pressurized soil. And to remove the pressurized soil and maintain the pressure inside the cutter head, you extract the soil through this screw conveyor, an Archimedes screw. So as you push the machine forward with these shove rams, you're creating pressure. You're releasing the pressure by drawing the soil out. And so the speed that you advance the tunnel boring machine, balanced with the speed that you're extracting the soil using the screw conveyor, means that you can keep the pressure in the chamber at exactly the same. Does that make sense?
Yep.
I know it does to you, Cooper. Oh no, you're not, it wasn't you said that, sorry. Same. So what you're trying to do is you're trying to balance the pressure in the front of the machine. So you've got hydrostatic or water pressure, and you've also got the weight of the soil. So if you're talking about the project that you're referencing in, I think it was in Ho Chi Minh, where the stuff came up from the bottom and onto the surface.
Oh, Hanoi City in Hanoi. Yep.
It was Hanoi, sorry. Apologies.
Yep, Hanoi.
So you've not just got hydrostatic water pressure, you've got earth pressure as well. So maybe I don't know, how deep was that tunnel? What was the depth of it?
Yep.
Do you know how deep it was?
How deep? Oh, I think I got the look up on the internet, and we'll call you later. But
No, it's not important. We'll just make an assumption. Assume it was 30 meters deep. Yeah.
30 meters.
Then normally the water table, I would imagine in Vietnam, the water table's quite high. So you've got 30 meters of water, which is 3 bars. You've got also soil pressure, the weight of the soil. So it might be more than 3 bars. The face pressure you need to employ, you probably need something like 3.5 to 4 bars face pressure.
Yep.
So if you have 4 bars face pressure, and you come across let's say a borehole that they did for site investigation, or an old pile, or something else that had been driven from the surface and not sealed properly, because your face pressure is a little bit higher than hydrostatic, then you're able to blow the stuff up to the surface. You asked me on an EPB if there's anything we can do about that, and the truth is no. There's no soil conditioning that will stop this soil going up through an unsealed borehole. It's literally impossible unless you seal all of those boreholes. This problem is unavoidable unless you completely take away the face pressure. Yeah. Sorry. So, in answer to your question, there's nothing we can do really. If the soil is fluid, it's always going to go up to the surface if there's a hole for it to go up through. Doesn't matter what ground conditioning you put in the front, it's always going to go up to the surface. Of course, that would be more difficult if the soil was more dry. If it's not super fluid, then the chances of it blowing up through this bore pile or this old hole is less if the soil is less fluid. But if it's less fluid, obviously that makes it much more difficult to tunnel.
In this case, I just wanna, how can I say? I just wanna express the message to the client, Of course, if we have no pressure ahead of the cutter head, right? If we have no water, no earth, so the bentonite or the
Forget about
conditioner will
bentonite.
go up.
We're only talking about EPBs. Forget about bentonite. We're not talking about slurry machines. You don't use bentonite on an EPB.
Don't use bentonite in EPB.
Not typically, no. There are certain special circumstances, but it's extremely rare.
Okay, so this information I need to check with the client because if we have no bentonite, so I didn't know why the bentonite goes up on the ground, and
Phương,
they told me they use EPB. Yep.
Yeah.
Phương, I still
Why?
have a concern here. Sorry, Richard. I need to clear the
Yeah.
information with Phương because as my information, the mud you see go up from the Hanoi Metro line, it wasn't the bentonite. Could you
Not
please check
bentonite.
again?
It was bentonite
Yep.
or wasn't?
It was bentonite or it was not bentonite?
No, that's what I thought. It was just dirty soil, yeah?
Phương,
It's just dirty
please.
water.
Yeah, could you please clarify the information with the customer?
Yep. I'm gonna ask them again to know it's the bentonite or mud. But you saying that if we're using EPP, so we will not inject anything ahead, the cutter head, right?
Yes, we will. We'll inject a lot in front of the cutter head. It'll be soil conditioning, not bentonite.
Yes.
Conditioning. Yeah.
Foam or polymer.
Okay, so
Occasionally,
I'm gonna ask them again. Yep.
Occasionally, people do use bentonite, but it's very rarely, and I'd be very surprised if they did use bentonite in this case. It's not something typically used on an EPB machine, and this is one of the points I wanted to make very clear to you guys. It's unlikely that was bentonite. Okay, I don't want to overcomplicate it for this first meeting, but sometimes they do use bentonite, but not to help with the soil conditioning. I'm talking about only EPBs now. They use bentonite sometimes because when you stop and you have to excavate the ring, you have to build the ring, then often what happens is that the pressure in the front of the machine drops gradually while you're building the ring. So CREG machines, HeroConnect machines, they have something called a Samsung device, which injects a little bit of bentonite into the top of the TBM. We're only talking about a little bit, not a lot. And that little bit of bentonite just maintains the face pressure while you're building the ring. Too much too soon, perhaps, but yes, sometimes they use bentonite or maintain face pressure, but we're only talking sort of like a few buckets. We're not talking about meters cubed of bentonite. Don't know if that makes sense. It's a tricky concept. So forget about bentonite. We're only talking about EPBs. So when we're injecting foam or polymer into the front of the tunnel boring machine, into the cutter head face through the ports that you saw where the foam was blowing out on the video, you're trying to turn the soil from being something dry and immovable into some kind of plastic material that's very movable. Like that, you can create a fluid, not fluid, but a paste at the bottom of the screw conveyor, and the screw conveyor can remove that paste easily. If it's dry soil, you're not able to remove it with a screw conveyor because it'll all hang up above the screw conveyor. It won't come out, it will just stick there. So you have to make the soil into a plastic movable mass. Does that make sense?
Yep.
Cool. Same, different. Okay. The size of your tunnel boring machine is probably, or you said it was 5.5 meters internal. But when you're setting the face pressure, you have to remember that the pressure at the top of the TBM is going to be 0.5 different to the pressure at the bottom of the tunnel boring machine. So when you consider your face pressure, typically you need to consider a face pressure that you'd experience 1/3 down from the top of the tunnel boring machine. Oh, that makes sense. Just a couple of other types of TBM. This is an open face machine. So if you've got very stiff ground, no water problem, then you just use excavators on the front of the shield to remove the soil and push forward. You don't see these very often nowadays because everyone's very risk averse. And when you use an open face machine and you come across bad ground, you've got a big problem. So it's not typically used so much nowadays. Another type of open face machine. Those slurry hydro machines. Instead of injecting foam and polymer into the front of the tunnel boring machine, you're injecting bentonite into the chamber, a bentonite slurry. The bentonite slurry is injected into the front, the soil comes through, the bentonite suspends the solids that are coming through the front of the machine, and they're pumped out through the extraction line. So completely different philosophy. On an EPB, you only have soil and foam in the front of the tunnel boring machine. On a slurry machine, you have a bentonite slurry that's removing the particles. So on a slurry machine, you don't have that screw conveyor. You just have this sequence of piping that's able to remove the slurry. Now, okay, MAPE can do both. We're able to handle both, and we have done both on many different projects. But like I said, there's not an awful lot of point in talking too much about slurry machines today because it's not something I think you'll encounter, though I'm happy to talk to you about it separately just for education purposes only, if you like. But the theory is you've got your tunnel boring machine. You pump the bentonite slurry in to the machine, the clean bentonite, and you extract the dirty bentonite. Typical slurry machine. And on the surface, you have the slurry treatment plant. You can see it's fucking big. So a lot of people think that slurry machines are easier, but you have to have a lot of space on the surface to install this plant to clean the slurry. So this plant cleans the slurry, and you send the clean slurry back down to start again. So it's a cycle. Clean bentonite in, dirty bentonite out. In here, you've got things like hydrocyclones and sieves and all sorts of stuff to clean out the slurry. You've got, what else have you got? All sorts of stuff anyway.
So in this case, can we use foam instead of bentonite, or we must use bentonite?
I'll make the point one more time very clear. Slurry machines use bentonite. EPBs don't. So EPBs only foam and polymer. Slurry machine only bentonite.
Oh, only bentonite. Yeah.
There are very strange exceptions, but extremely rare. I don't think in the situation in Vietnam it's likely that there'll be any variation from what I've just said. I think it will be EPB, foam and polymer, slurry machine, bentonite. Now, there are polymers you can add to the bentonite on a slurry machine that we also supply, but we're not talking about slurry machines today. But I'm hoping that you've kind of already got a good idea about the difference between slurry and EPB machines. You don't want to be going into a meeting with the client and start talking about bentonite when they've got an EPB, because they'll look at you like you're crazy. Point made?
Yep. Yep. I'm gonna talk to customer to take deeper information, and we'll get back to you. Yep.
Yeah, but be careful to talk about bentonite when you're talking about EPB, because honestly, if I were the client, I'd just say, get out. You don't know what you're talking about.
Yeah. Yep.
Okay. Sorry, that sounds a bit harsh, but it's just I have been a tunnel manager in my time, and I did kick a lot of suppliers out. I was awful. I was a very bad tunnel manager when it came to suppliers. I was very impatient with them. Okay, so hard rock machines. This is where you have soil, either very, very hard soil, so you need no face pressure. So you can see there's no shield on this machine. It's just got these grippers. I need to highlight the pointer, don't I? Wait. Can you see these red things here?
Red things. I
Yeah.
just see 2 TBMs, a yellow one.
Yeah.
With
So you
white
look at the one with the orange cutter head. I've got my laser pointer on these red things.
Oh, I see that. Yep.
Yeah, they're called grippers.
Grippers.
So you've got no segments in a hard rock tunnel. They're just cutting through the rock. So you don't see any segments behind the tunnel boring machine. So if you don't have any segments, you have nothing to push the TBM forward off. So in a hard rock machine, you have these grippers that push in and out, and they grip on the side wall of the tunnel. When they grip onto the side wall of the tunnel, then the machine could push forward, because everything has to push off something. Again, I can give separate talks on hard rock machines, because you probably do have hard rock machines some places in Vietnam occasionally. I think Hainan Pass, or does that ring a bell? I think they had Robin's hard rock machine there. I might be wrong.
Robin is real famous in hard rock machine, right? Robin's.
Yeah, they are famous in hard rock machine, but and we're a very good relationship with Robins, but unfortunately they don't seem to be doing very well nowadays and don't seem to sell many TBMs. Seems like CREG is selling everywhere. So the one on the left, the yellow shielded machine, that's a hard rock machine. But this hard rock machine has also got a shield on it. So if it has a shield on the back of it, you can assume that they're going to build segments. So it's a hard rock machine, but it's also going to be segment lined. And on that machine, you don't have these grippers. You just push off the segments like you do on every other tunnel boring machine. Pipe jacking machines, I'm sure you must have seen them around. They're pretty much everywhere. They're ubiquitous in Asia Pacific for small diameter pipes. I know they've done quite a bit in Vietnam of pipe jacks, but maybe you've seen, maybe you've not seen. But even these machines are either slurry or EPB. We can sell to these machines, we can sell our materials to these machines, but obviously in a much lower quantity than you would on a metro tunnel. But it's still very interesting to talk to these guys. Quite often we have solutions for these kinds of projects that can be very useful for them. So, other types of tunnel boring machines that are very, very strange, you're not going to come across so much. You've got under and over TBMs where they're actually joined together or can be separated and act independently. You have square TBMs, which are a recent innovation. We've had maybe 3-4 different projects in Singapore where they've used these square TBMs. They don't so much, you get more square than this. Instead of these cutter faces rotating, they kind of oscillate. So they push in and out on this axis. So when the cutter comes round to here, they can push out further. Okay, not necessary to talk about. And there was one of these in Hong Kong a couple of years ago, where they have a TBM that comes out the side of the TBM that does cross passages. Again, not going to happen in Vietnam this year. But you can have combinations of everything. You can have slurry machines that convert to EPB machines, and there are other machines called sorry, I'm screwing with my own head at the minute. Where you have continuous excavation, double shield machine. But again, we don't need to talk about those. But if you want to talk about them later, very happy to. So we're only going to talk about EPBs today. We can talk about slurry a little bit if you want. The one thing I could say about slurry machines is where you have the blowout situation that we were talking about in Hanoi. There are things that we can do to minimize the chances of blowout on a slurry machine, but we can't do that on an EPB. So on a slurry machine, typically the density of the slurry is about 1.2. But what you can do is you can weight the slurry. You can add things like hematite, iron ore, or you can add calcium carbonate to the slurry, so you can make the slurry heavier. And if the slurry is heavier, you need more force to blow it up to the surface. But on an EPB, that's just not practical or possible. So EPB, the goal is to turn a soil that's very, very dry, potentially, something that's not pumpable, something that's not movable, by adding ground conditioning, foam or polymer. You can turn it into I don't know, it looks like dog shit, doesn't it? But it's you need to turn it into something that's plastic and malleable. So you can see that the soil at the top is the same soil, but just with the addition of foam. This soil, you'd never be able to get through the screw conveyor without adding foam. This soil is nice and plastic, so yes, you would be able to get it through the screw conveyor and out. Skip that one. Skip that one. Skip. Okay, so EPB. Why do you use foam and polymer? Going back to your sort of like school days, you know that hydraulic circuits exert pressure, same everywhere. So if you exert pressure on a fluid, then it's going to transmit that pressure a long way away, and it's going to be exactly the same pressure if it's a fluid. That's the basics of hydraulic systems. So if you have soil in the front of the tunnel boring machine that's fluid, the pressure is going to be pushing on the face uniformly. You're going to have a uniform face pressure. So you're going to push on the face at an equal pressure all over. And that stops the soil from the front of the tunnel boring machine collapsing and falling into the tunnel boring machine. If the soil's dry, you don't have that universal pressure on the front of the machine, and you can get soil falling into the machine, and you can create subsidence. You can create a lot of problems with over excavation if the soil's too dry, because you don't have that universal pressure on the face. Number two, wear. Obviously, if you have a dry soil, then the wear potential is much, much higher. You're going to wear out the cutter head. You're going to wear out the rippers and the teeth on the front of the machine because it's dry. It's much more abrasive. When you put foam into the front of the machine, the soil becomes much less friction.
Sorry.
So this is very easy to see on a tunnel boring machine as well. If you get the soil is coming out hot, if the soil's coming out of the screw conveyor and the soil's hot, then you know you've got too much friction in the front of the machine. It's not just that wears out as well. If you've got the soil too dry, you can also wear out the screw conveyor, even though the screw conveyor is made from very thick metal. If you're going through abrasive soil, then you can wear down the screw conveyor. So one of the things that we always ask when we talk to the client would be how abrasive is the soil, because we want to make sure that we can minimize the wear.
Bất kỳ cái gì đó nó có cái gì giống giống
Improve
đưa lại
flow.
đó ra.
Number 3.
Nó gây chậm
This one
máy á, anh chẳng bao giờ anh dùng.
quite important because you want the soil to come from the front of the machine. You want to go into the chamber. You want to go it out of the screw conveyor. You want it to go along the belt conveyor. You want it to drop into the skip, or you want it to go to the surface, depending on how long your belt conveyor is. But all of this is a cycle, and often we have to adjust the ground conditioning just to make the soil suitable so that they can empty the skips. Because if the soil's going into the skips and it's too dry, when they try and empty the soil from the skip, half of it sticks inside. So sometimes we have to make it more wet just so that they can remove the soil from the skips. You always have to think of these tunnel boring machines. Think of it as a sort of like a factory production. You're excavating, you're building the ring, you're removing the soil, then you excavate, build the ring, you're removing the soil, and all of this is a process, and the whole process needs to be optimized. Everything you can do to optimize the time that it takes to excavate the ring, the time that it takes to build the ring, all of these, if they're optimized, then the tunnel finishes much faster. Everybody's happy except for the workers who lose their job much faster. Reduce
We have,
downtime.
excuse me, do we have any unique feature comparing to other guys on the market? I mean, a foam, a conditioner. We have any special features need to be specified into the tender dossier? What do you think?
I personally feel that our foam performs better, but that can only really be demonstrated on the tunnel boring machine. There are other things that make our foam superior, but it's difficult to, and I have to be careful how I say this because I don't want to be insulting to Vietnam, but I don't think that environmental aspects are as important in Vietnam as Europe, say, for example. So our foam is very environmentally friendly. So you can take the soil out of the tunnel and you can use it for growing agricultural products, for example. You don't need to have a special disposal site where you're concerned that the soil has toxins inside. So all of our foam is extremely biodegradable, and it can be used for any purpose you want after the soil has been removed. It's important in some places. I'm not sure how important it is in Vietnam, but I still think it's important that you guys stress this point, saying you don't need to make any special provision for disposal of this soil, because the soil that's going to come out of the tunnel is going to be clean, can be used for anything.
Yeah. I think a few years ago we're not care about the environmental problems, but nowadays we're more caring about that kind of problem, because after removing the soil, you got the discharge the soil, and we have almost no discharge place in around Hanoi right now. Yeah, you can damage the environment, the environment, and we have real big problem right now in Hanoi City with the fine dust and environment problems. It's real important right now. So yep, I
Well,
think if
yeah.
you say, but
Push this,
we
push this
can
point.
we can. Yep, you please.
No, I say push the environmental aspect because if, like you say, if they're struggling where to put the soil, if they understand that they can put this soil and you can use it like normal soil anywhere in the world, then the pressure of having to find a specific special disposal area becomes you have much more options to dispose of soil.
Hi, Richard. To be
Yeah.
clear, as Mr. Phương already said, a few years ago, maybe the environmental aspect is not a big problem, but nowadays, our government care about the government is very care about the environment aspect, not only for the building construction side, but also for the specified project like the metro. In the metro line specification, they mention very clear everything about the environmental aspect, like the supplier must have the full certification, for example, the ISO 14000 biology test report. But the main point I want to say here is not only MAPE, not only us consider about this, but also our competitor. They all can provide the same certificate. So
I don't think they can provide the same, Mr. Ann. I think we've gone a little bit further than these guys.
To be clear, Richard, to submit the first time submit document to the project, they care about how many document you have, and after that they will go deeply inside later. I mean, all of our competitor have the I say they all have the necessary document. So Mr. Phương want to mention here is what is our advantage?
We have
Yeah.
more stringent documentation. Our documentation is, let's say, better.
We have to prove it.
Well, it's difficult to prove it, and I know it sounded like I was being harsh on Vietnam, but I like even Singapore. They talk about the environment, they talk about biodegradability, they talk about toxicity, but actually they just talk about it. They still use any foam they want. They use toxic foams in Singapore. So I don't know if you've heard of the expression virtue signaling. They talk a good story, but they don't act it. This seems to be a case in many countries now where people talk about environmental consideration, but they don't actually do.
So in Singapore, they still do the toxic foam, even in Singapore.
Less than before, but there are no specifications relating to it. So, for example, there was a company called TAC, and they provided foam on a project in Singapore. And when they disposed of the soil, then they killed lots and lots of fish. And there was a lot of shouting about it for 3 months. And then the same supplier came back and started supplying foam again. So they don't really. Okay, it's not my job to speak badly about Singapore either, but it's one of those things that they talk big, but the action doesn't support the words. Okay, so the other big advantage on our phone. You might say this is arrogant. I don't want it to sound arrogant, but we also, when the tunnel starts, we also provide the technical service to make sure they optimize how to use it.
Yeah.
And this is something where we can gain a great advantage because within MAPE, we have the knowledge to go onto a tunnel boring machine and adjust the ground conditioning and make a significant difference to the performance of the tunnel boring machine.
Yeah.
So it's not always about the foam itself, but how you use it.
Mhm. So we are doing the sub technology, but we have knowledge about the whole package, right? We also have the knowledge
Yeah,
about
yeah.
TBM or something like. We can
So-
consult customer.
This is where I do become arrogant. I'm supposed to be amongst the top 3 experts in ground conditioning in the world.
Yeah.
So if you want somebody who knows what they're talking about, yes, I do know what I'm talking about, and yes, I can make a difference.
Impressive. Because I think, most of the TBM system right now in Hanoi was not so optimized.
No, they're very, very rarely optimized. There are
Really?
lots of things
I,
you can do
I
to
don't
make
think
it work
so.
better.
Yeah. As my knowledge, a TBM should go for 15 to 20 meters per day. But right now in Hanoi, it's around 9 to 10 meters per day. So I don't think that was really optimized. So maybe we can jump in, and we can make it go faster. I think so.
Yeah, I think so. But I'm like, what you've really got to consider is what's the speed for the excavation cycle. So let's say your averaged ring is 1.5 meters long. What's interesting is how long it takes to excavate that ring, because there might be other reasons that the cycle is slow. Maybe the logistics of getting the soil out
Yeah.
of the tunnel are bad, or maybe it takes them 1.5 hours to build a ring. What we're considering with foam is we're only considering the speed of the excavation. But the whole cycle of TBM operation needs to be looked at. But what we can help with is obviously the excavation cycle. We can't really help them with ring building. We can't help them with their logistics. If they've set up shit logistics, it's not MAPE's problem.
Yeah.
So again, we're talking about foam on EPDs, reduced downtime. Oh no, it was safety of workers first. When you go into the front of a tunnel boring machine, it's incredibly unpleasant. More often than not, the temperature going to be over 40 degrees centigrade. You're going to have 100% humidity. Everything's very, very slippery. When you have to change the teeth on the front of the tunnel boring machine, these things are fucking heavy and very difficult to maneuver and change. So the less you have to do cutter face changes or teeth on the front of the tunnel boring machine, the better. It also saves you a lot of time if you don't need to change the teeth by every 100 meters. Quite often as well, you have to do these changes in compressed air. And compressed air interventions are very, very complicated, costly, and dangerous. So everything you can do to improve the safety of the workers by reducing the number of times they have to go into the front of the tunnel boring machine to change the cutter teeth, the better. It's I've done some very unpleasant jobs in my life, and changing cutter teeth is definitely in my top 3 of you don't want to do that, especially now because I'm old and fat. So reduced downtime. Again, if you're not doing if you're not wearing out the tunnel boring machine, of course you're going to reduce the time it takes to maintain the machine. And you're saving costs as well. If you can do 20 rings a day instead of 10 rings a day, then of course you're saving costs. You're saving huge amounts of costs. So this is just going through it. The other things I've not mentioned is when you put foam and polymer into the soil and you make that plastic paste, then the soil also becomes impermeable. So when you have the dry soil, you pour water on it, then the water's just going to fall straight through the soil, so you're going to lose water pressure. Inside the chamber, there's a path for water everywhere, but when you make the paste with the foam and polymer, the soil becomes impermeable, and therefore you're not taking any water from the front of the tunnel boring machine. You're not drawing down the water table, so you're reducing any kind of risks of subsidence. The rest we spoke about. Okay, the more soil comes through the front of the machine, the more risk you have of settlement. So everything to do with foam and polymer is about only cutting as much as you need to advance the tunnel boring machine. You don't need to cut more than that. One of the things that you often need to consider is that the tunnel boring machine is bigger by some diameter than the outside of the segments. And also the tunnel boring machine is normally tapered a little bit. So the front of the machine is a little bit bigger than the back of the machine. So nobody is perfect. And even if you operate a tunnel boring machine with maximum efficiency, you're still going to get something called face loss. You're still going to lose about 3%. You're going to get 3% additional excavation. So you're almost always going to get some kind of surface settlement. The surface settlement can be anything between like 0 and 30 millimeters if you're operating the machine optimally. But obviously, if you're not working optimally, then the surface settlement can cause shit like this. You can get meters pulled down. You can get all sorts of shit happening. So being able to keep that face pressure optimally and just pull in the soil as much as you need, then it's critically important to a successful operation. Okay, we spoke about reducing the wear. These are called rippers. Rippers are used in soft ground. Something I should have probably mentioned before. But yeah, rippers and scrapers are used in soft ground. So what you see here is soft ground, but even soft ground, when I say soft, I mean less than 15 MPa, 1.5. And even in soft ground, you can get this situation where you wear out the front of the machine. And this is one of my, when I worked for Nishimatsu, we had to replace this nose cone on the front of the tunnel boring machine. And again, working in compressed air, trying to replace this that weighs, let's say 800 kilograms, was quite difficult. Difficult is very polite. Improved flow, we spoke about it. You want the soil to come out like this. You rarely see it as good as that because that's basically clay and it looks perfect. In that case, it was. We spoke about that. You can pull back the front of the tunnel boring machine, sometimes like 100, 200 millimeters. So you're able to get into the front. So this is the face of the tunnel boring machine. Sorry, the face of the ground. This is the face of the cutter head. You've got very little room to work in. And you can see all the soil is dried, caked on. These things weigh 30 kilograms plus. It's a difficult business. I only show this photograph because it just amuses me, because as shit as it was, I still found an Indian guy asleep on his shift in the front of the cutter head. I don't know how he slept. It's literally impossible for me to sleep there, but there he was.
It looks a little bit dangerous, right? I'm real afraid that the soil will collapse and you got be buried alive.
Yeah, well, that and oh, there are all sorts of horror stories on tunnel boring machines. Sometimes people forget people are in the front of the machine and they turn it on. Can you imagine being in the front of a tunnel boring machine and they start it turning? My goodness. This happened too many times. Okay, reduced downtime, smooth operation, better cycle times, reduction in torque, so power you need to turn the cutter face. If you can reduce the torque, you reduce the power that's required. And it's something not many people consider, the power saving you can get by ground conditioning. You can pay for the ground conditioning just from the electricity you save. So
This is just we take this from the newspaper or research, or we do internal research to have this diagram.
I've just used the diagram. You're never going to be able to prove it.
Do we have any test report or internal test report to show that we can reduce
every project
the
is
power?
completely different, and to be quite honest, no. Because you're never going to find a contractor that says, okay, we'll go for 10 rings and we're not going to use any ground conditioning, and then we'll put your ground conditioning and then we'll see what the improvement in torque is. It doesn't really need a test report. It's kind of obvious as well. If you're trying to move a soil that's not plastic and unmovable, then the force you need to do that is much, much more than to move a plastic soil.
So this is just kind of like general research, right?
Yeah, this is general research. So the reduction in electricity can be, let's say, 50. This is just something that actually our competitor did. Condat did this, but we can reduce the power requirement by over 60%. So if you reduce the power to operate a TBM by 60%, consider how much money you're going to save.
Yeah.
Going to go quickly back. Show you this. On the front of this machine, these hard rock machines, you can see they've got these round cutters. They're called roller cutters. On a soft ground machine, you have these they're called rippers and scrapers. The cutoff's about 15 MPa, like I said before. But you can always understand from the machine supplier whether the ground's kind of hard or soft, depending on what cutters they install on the front of the machine. So roller cutters, you always put on hard ground, and rippers and scrapers. When I say rippers and scrapers, I'm talking about, that's a ripper. And you see these on the sides of the openings, they're scrapers. So anything below 15 MPa, you probably see this configuration. You can't switch them about too much, because if you use a roller cutter in soft ground, they don't rotate, and so they just wear away and they don't cut any ground. And if you use rippers and scrapers in hard rock, then they're just going to wear away after about 5 meters. It's not really so important, but it's something that it is important, but it's just for your knowledge. This one needs updating a bit, I must admit. I like foam is foam, and we all know what it's like. What you really want to generate when you have your ground conditioning on your tunnel boring machine is you want to create a foam that looks like shaving foam. The smaller the bubbles, the better. They're stiffer, they're stronger. Oh, we've spoken about that. Spoken about that. Never mind about that. So, yeah, okay, we come to this bit later, but on the tunnel boring machine, you put our IBC of foam and you add water to it, and then you add air to it. And sometimes you add a polymer also. You can inject the polymer through the foam lines, or you can inject it separately. There are all sorts of rules that make that different in different cases. Polymers are different. Polymers have different actions. You can have polymers to increase the viscosity of the soil. You can have polymers to decrease friction. You can have polymers to dissolve clay. All of these need to be considered based on the soil characteristics, which I'm hoping over the next few weeks you'll be able to get some soil from the project, send it to Singapore. And what I also need is they call it different things in different countries, but in Singapore, for example, they call it the Geological Interpretive Baseline Report. So, and they give you this longitudinal profile of the soil and conditions throughout the tunnel. And with that and a soil sample, I'll be able to generate a report that you can take to the client, and the client should be able to look at that, and or the customer, in fact, and they'll be able to give a rough estimate of, one, how much they need to use, and two, answers to any specific problems they might have. I don't know if that's something you can get for me over the next few weeks. Hello, Vietnam.
Yep.
You can get that.
You're talking about polymers?
No. Oh, maybe you disappeared for a while. What I need is the Geological Interpretive Baseline Report, including longitudinal profiles and soil samples.
Okay, I'm gonna take that from the customer right now. They are doing the surveying job.
Yeah, you know what I mean by longitudinal profile. It shows you from the geological investigation, they'll have a report, and they'll also be able to produce a cross-section of the tunnel showing the different soils and where they are, and the length of the tunnel, the depth of the tunnel, that kind of thing.
Yep. So I'm noting here longitudinal, right?
Sorry,
Profile.
can you repeat that?
Longitudinal profile and
Yeah,
soil investigation report.
Yeah, and hopefully some soil that they took from boreholes that they did along the alignment. That in the soil needs to come obviously from the tunnel alignment. There's no point taking soil from the surface. It needs to be from where the tunnel boring machine is passing through.
Yeah. So you need the soil the soil in the tunnel route, right? Tunnel route.
Yeah. Maybe they're not ready for that to do the soil test, but I'm sure they're able to pass you the paperwork.
Right now, the subcontractor is evaluating the conditioner from a few suppliers in Vietnam. I've just taken their how can I say, their internal report, where they say, oh, from this supplier is the real good stuff and used for Michelin 3 in Hanoi. and this supplier they got to import, or how can I say, they got to import from the other country, so we may have shutdown schedule, something like that. I'm gonna send you the conditioner from the other rivals in Vietnam. We have Seeker, NCB fee, yep, and also ask for the soil investigation report.
Yeah, okay.
Yeah.
As much in English as possible, please.
In English, of course, of course.
Oh,
I
you
think
say, of course. I'm like Vietnamese is one of the most complicated languages in the world.
just the newspaper. It's the newspaper I've sent you the article. But you know, in how can I say, for the tendering dossier, it must be in English. Yeah. Even if
Okay.
you see the mutual life file I sent you, yesterday you can see the specification of mutual
Yeah.
life file.
Yeah,
It
I saw that, and
yep, yep,
I did read it. Oh, I didn't read all of it,
yep,
obviously, because I only read
yep,
the bit
yep.
about the tunnel boring machine. But there was nothing in there that was anti competition.
Yeah. It was, you know, awarded to a China contractor, but it wasn't in Chinese. You know, it's still in English. Of course,
Yeah.
must be English.
Okay, cool. All right. A few tests we did in Italy, just to sort of like give you an idea of polymers. The top one is just adding water. You can see it doesn't hold water at all. It just all the water passes through. The soil's permeable. It's not good for tunneling. So on the second one, they added some polymer, and if anything, they added too much polymer, like water absorbent polymer, which in it says Mapei polymers, but ours is called Mapedril N1, and it just sucks out the water. It's the same kind of polymer that you use in babies' nappies, or if you say diapers in, I don't know. So in English is nappies. So it sucks out the water from the soil. It also lubricates. It also stops clay from being sticky. So it has an ionic action on the surface of the clay particles and prevents clay from becoming sticky, which is also very, very useful on an earth pressure balance machine because you want to prevent any kind of adhesion to the cutter face, to the cutter teeth, and helps a lot when you're taking the soil out from the screw conveyor into the skip. So, for example, we sell a lot of Mapedril M1 in Thailand because they have a lot of sticky soil, and also they have a lot of water-heavy soil where we're able to control the water by using this polymer. These are just a few of the polymers that I spoke about before. As and when I get the longitudinal profile, I'll be able to advise on which ones might be useful or not. And certainly when it comes to production, there's no reason at all you can't produce the foam in Vietnam. It's not a very complicated formulation, and I see no reason at all why you couldn't produce any of this in Vietnam, other than the fact that you don't have ISO yet. Is there any word on that, Tony? Are you getting your ISO certification or not?
No, Richard. Just
yeah. We got the ISO certification, Richard.
Okay,
We got
good.
the ISO 14001.
Yeah, 20 years too late, but well done.
Yeah. Okay. Thanks, Richard.
It's not important. Important. Lots of different types of polymers, depending on case by case. Spoke about that. Sorry, I don't know if you can see the spinning wheel of death. I've got to wait for it. Sometimes people want to use a dispersant polymer just to clean the cutter face before they do an intervention. Before they go into the cutter head, they can put dispersants into the front of the machine, so it makes it easier to clean and do the cutter head changes. This is a very simplified version of a graph that was produced by a guy in Germany, and it's just it's a simple concept, but a concept that you might need to kind of understand a little bit. I don't know if any of you remember from university when you did Atterberg limits. So, for example, when you have a dry soil, you add water. It's kind of very, very stiff, and then you get to the plastic limit where it's movable, and then you get to the liquid limit where it flows as a liquid. And these are called Atterberg limits, if you're not familiar. This is all on the Geological Interpretive Baseline report, which is kind of interesting. But a lot of soil, if you add a little bit of water, it's not so sticky. And then you get this zone of how much water you add to your soil, where the soil becomes extremely, extremely sticky, and then you get to the point where it's so wet it stops being sticky again. It's just there's a much more complicated version than this that I could spend an hour describing to you at a later time if you're interested. Okay, I don't know how much you know about where you use clay, foam and why. But typically you use foam at say 1 to 3% concentration. So you put your IBC on the tunnel boring machine and you go to the driver's cabin on the TBM and you say how much you want this foam diluting. There's a screen on the tunnel boring machine where you can set all of these parameters. So I've just given an example here where you have a 3% foam concentration. So let's say that's Mapei's Polyfoamer FP 3%. You dilute it with 97% water. And when you use high concentration and low concentration of foam, is if you have a low concentration where you've got well-graded soils. So by well-graded, I mean you've got clay, silt, sand, coarse sand, and maybe pebbles. If you've got very, very well-graded soils, then you don't need much foam concentration. But if you have a soil that has big size fractions missing, so maybe you have clay, silt, and pebbles, but no sand, you've got that missing portion, then you need a higher concentration of foam because the foam needs to overcome the problem of missing fractions. All of you guys will have made concrete before. With concrete, I'm sure you know that, again, you put in cement, you put in fine sand, coarse sand, fine aggregate, coarse aggregate. And the obvious reasons why you do that is so that you have a straight line or a good grading of the stuff you put into concrete, so you can make it fluid, so you can pump it, or you can do what you want with it. It's the same with soil. If you have a good graded soil, then you need less additive to make it work properly.
So 3%, we're talking about the ratio about weight or about value. 3% foam comparing to water, you're talking about kilogram per kilogram or meter cube per meter cube.
It doesn't matter because foam's got the same density as water. Think of it how you like. All of our foams have got the same density as water.
Oh, same density. Yep.
So anyway, you add the water, and then you add the air. Adding the air is one of the sort of like stranger things on a tunnel boring machine. Of course, you need to add air, otherwise it's not fun. But it's the one thing on a tunnel boring machine that you shouldn't really mess around with. Don't adjust the air. Set it at say 10 or 12, and don't adjust it, because if you adjust the FER, then you're making a huge change to the amount of fluid that's being injected into the front of a tunnel boring machine. So if you change the FER by, let's say, 1, you're adjusting what's being injected into the front of the tunnel boring machine by 10%. And it's a big gap. It's too much. So always remember not to change the air. Leave the air setting. The rule of thumb is that if you have dry soil, you need wet foam, and for wet foam, you don't need much air. If you have dry foam, you need a lot of air, and so if you've got wet soil, you can have wet foam. So this is how you think about the adjustment of the FER, but only do that at the beginning. Don't change it unless you have to. The foam injection ratio. So then you have to think about how much foam. What's the volume of foam that you add for every meter cubed of soil that you excavate? Is that clear?
Yeah, see that.
Yeah, so your normal project is going to have a tunnel boring machine that lets you automatically select FIR's foam injection ratios, and on the tunnel boring machine, it shows something normally between 20 and 60%. So between 200 litres and 600 litres of foam for every metre cubed you excavate. 60% is quite often not enough. Sometimes you have to add more. Just a couple of typical values. I remember I've attached this presentation anyway, so it's something you wanted to go through. So from everything I've said before, you've got some sort of like basic idea of what foam is. If you send the stuff to the laboratory, you can increase the confidence of what I get from your GIBR and longitudinal profile. Quite often, ground conditioning is not really so much scientific. It's kind of knowing what you're doing more than anything else. Common sense, number one. When you make a change to ground conditioning on the tunnel boring machine, you always have to remember it's going to take probably more than one cycle of excavation before you actually see a change coming out. I get very frustrated when I go on tunnel boring machines and you can see the driver and the shift engineers and the section engineers and the project manager. They're coming down and they're adjusting the foam every 20 seconds or something like that, and it's absolutely nonsense. And they can make a huge fuck up by adjusting it too often. There should be one guy left in charge of the ground conditioning and nobody else should touch it. Interesting rule of thumb is that in an average tunnel, you need 1 litre of product for every metre cubed of soil. So if you're tendering a project and you don't really understand what the ground condition is like, then you can start off by just making the assumption that you need 1 litre of MAPE foam for every metre cubed of soil that they'll excavate. And if you know the length of the tunnel, the diameter of the TBM, then you can get a very good indication of what the amount of product they need for the job. All projects are different. Always put a picture up in the tunnel boring machine where the ground is, so they're ready for any changes. Always have additional on the job site in case they come across any kind of very bad conditions that need immediate action. Where you get changes is the majority of problems, because the interfaces between different soil types is where you get normally high water flows or just a lot of different issues occur. Never believe what the TBM screen tells you, because quite often they do all the wiring, piping, hosing, they get it all wrong. You need to do manual checks on the ground conditioning as well to make sure that what the computer says is what's actually coming through the pipes. The tunnel boring machine in the driver's control cabin, you're going to have 3 separate ways to adjust the phone. You're going to have manual, where you can turn on each individual line on the front of the machine separately. So you can test line 1. Typical metro tunnel is going to have 6 or 7 injection ports. You can turn them all on separately and check each line separately and make sure that they're all working. So that's why you need the manual situation. Semi-automatic is where you set how many liters per minute of foam you want to go through each port. So you might say that you want 40 liters of foam to go through each port when you turn the machine on. So that's as soon as you turn the excavation on, then you're going to get 40 liters of foam come through each line. You can adjust that. You can do 30, 40, 50 through each different line. You can put separate figures for each line, but that's not really the way we would ever want to go with a tunnel boring machine. You really need to set it to fully automatic. So on fully automatic, you type in what the foam injection ratio is. You type in the concentration of the foam, and you type in the foam expansion ratio, the 3 things that we spoke about earlier. And with that, it's able to understand from the speed that the TBM's advancing how much foam needs to be injected. So it's linked to the speed of the machine. So you have the speed of the machines measured by things called linear extensometers that are on the shove rams. So it knows how quick the machine's going. So if it's going fast, it injects more foam. If it's going slow, it'll inject less foam. If you don't do that, then you get this weird thing where the tunnel boring machine goes slow, then fast. It goes slow, then fast, as it kind of has too much foam, too little foam. So when you set it to fully automatic, you can get the correct amount of injection at whatever speed that it's going at. I just said that. So for fully automatic, I mean, it's a very obvious statement, but I'd still say that 6 out of 10 tunnel boring machines don't use fully automatic. And that's another one of the things that we can go onto the tunnel boring machine and set up for the guys, and it's going to make the machine go significantly faster. In my experience, a tunnel boring machine, if you set it to fully automatic, is typically going to go at least 30% quicker than if you have it on semi-automatic. Yeah, important to keep everything simple. Don't make it too complicated. A lot of people talk about the fact that if you've got high face pressure, then you need to inject more air because the size of the bubble gets smaller and the compression. Yeah, don't go there too complicated. Lab tests are good, but they're never as good as actually going onto the tunnel boring machine and using it in anger. Okay, so stupid points, but they're kind of obvious. If the ground's very dry, you don't use foam to make the soil wet. You have to add water on it through a separate line to make the ground more wet. So I use this ridiculous example where when you wash your hair, if you put shampoo on your head without water, then you're not going to make any foam. But if you wet your hair first, then you can make a lot of foam. It's the same with soil. Otherwise, you're just going to use the ground conditioning to make the soil wet. It's great for MAPE, means we can sell more foam, but practically it's stupid. You need to add enough water. If you remember back to the Atterberg limits that I spoke about earlier, you need to add enough water to make the soil up to its plastic limit, and then use the foam to lubricate the soil at the plastic limit.
Are we talking about the same conditioner? The conditioner for hairstyle is the same conditioner we're talking about here? Same chemical?
No, we're just talking about foam in general. It's different.
Yeah.
It is different. I don't know if it's very different, but I like it's certainly different.
It's just an example, Mr. Phương. Richard tried to give us the image for your
Imagine,
easy
right?
understand.
Yeah.
But Richard, your example is very interesting. I mean the conditioner. For me, I never put the conditioner when I wash my hair.
Yeah, but okay, it'd be very interesting, Mr. Kwon, if you when we start using our foam on the TBM, take a small bottle and wash your hair for 1 year. Let's see what happens. So the ground's too wet, dry it up, use a polymer like Mapegel M1 to suck the water and make it more dry. So the rule of thumb, you can't see my video, can you? What am I doing? Sorry. Anyway, if you can squeeze the soil in your hand and you get soil squeezing out through your fingers, that's the condition you want. That test is better than 100 laboratory tests. It's very visual, it's very hands-on. If you can't squeeze it out of your hand, it's too dry for the tunnel boring machine. If it falls out your hand, it's too wet. But if you can just squeeze the soil in your hand, then you've got the correct amount of water and foam. Again, going into too much information, I guess, but these are things that if you've worked on a tunnel boring machine before, then they become more obvious. But if air blows through the screw conveyor, because if you're adding too much FER, foam expansion ratio, and you quite often get the air escaping from the foam and creating a void in the top of the tunnel boring machine, which when you rotate the cutter head, that void of air gets brought down to the screw conveyor and it fires through the screw conveyor as blasts of air. If you get that, then the soil's too dry. You need to make it wet. But that's something that you'll come across. It's a little bit dangerous as well because you can quite often get to the situation where you get 3 or 4 meters of air just suddenly blast out of the tunnel boring machine screw conveyor, and it can get very messy. Important things. I'll give this presentation to people doing a master's degree in tunneling in Turin. So it could be more complicated. It could be simpler. It's somewhere in the middle. You'll never be able to do ground conditioning on a tunnel boring machine unless you spend a few days on a few different machines to get a good handle or to get a good understanding of what to do in different ground conditions. The more experience you get, the more you learn. It's not something you can just walk onto a tunnel boring machine and do well. You might be able to do it from listening to what other people say and stuff like that, but you'll never be able to do it properly unless you've actually had hands-on experience. My opinion. But you can certainly give advice. The only way you're ever going to get good at doing this is by doing it yourself. I'm not going to make you do any math problems. Don't worry about them. This is obviously when you put soil into when you put foam into a soil, then the volume becomes bigger, so the density changes. It's because every tunnel boring machine also has a density weigher on the belt conveyor, so you need to understand what the density of the soil is so that it can accurately calculate the volume for excavation management. You don't want to excavate too much. Too much excavation, you get settlement. Equipment used, so TBM and backup. Really do need to get better photographs than this, I'm sorry. This is the polymer dosing unit. So you have water going in through here. You have a screw mechanism. Depending on the speed of the water that comes through here, it sucks up a predetermined volume of polymer and puts it into the injection line. These things are quite simple and can be used very easily on tunnel boring machines, but a lot of tunnel boring machines don't have these fitted, but we know where to get them from. This is the typical foam generation set. Because CREG copy Heron Connect in everything, then it's going to look remarkably like this. But I believe that the purple line is the purple lines are the water and concentrate, and the yellow lines are the air. So you have flow meters here, and you can measure the amount of water and foam going through here. You have a flow meter that measures the amount of air, and that's how all of the information gets back to the driver's cabin. Here you have a kind of a volute mixer where you generate the foam inside there's thing like like a metal gauze. It just means that the air and the foam and liquid mix together properly. You can see the air here. Here you've got a bypass valve. So if you open this valve here, you can see what the quality of the foam is that you're injecting. Typical tunnel boring machine. If you see these red spots on the front, these are the points of injection. They've got a non-return valve on the end of them, so you don't, when you turn them off, the soil doesn't get drawn back into the pipes that are injecting the foam. But trust me, they don't work. They always wear away, and it's a problem. Okay, I think I'm showing this. This was my tunnel boring machine back in 2000. It's got almost no teeth. It's got no rippers. It's got no scrapers. It's completely fucked. We had about 10 meters to go till the end of the tunnel, and we didn't want to go into the front and change the teeth, so it took us about a week to finish, basically pushing through with a bulled TBM with nothing on it. So this is what happens. This is what happens to a TBM when you don't pay attention.
The beginning they have the cutter, and then it was abraded to this, or they have no cutter this at the beginning.
This was the beginning.
Oh, beginning still have.
This was the beginning. This was the end.
Yeah.
So okay, I can't blame anyone else for myself, but at that particular time, I was working for the contractor, so I was trying to save money. Yeah, okay. Yeah, so even back in 2000, you can see I was fat. This is the way that you see it in the driver's control cabin. So when I spoke about, this is okay, Budapest, so this is Hungary. You can see here that you set on the TVM, you type in here 30% foam injection ratio. This is the, okay, it's German English, but that's the concentration of the foam. There's no polymer in this case. You set the foam expansion ratio here. So for fully automatic, you just set those three things, and also the distribution. So you remember the holes on the front of the tunnel boring machine? This is how you distribute the foam. So in this case, you've got only using ports 1 to 4. Typically, lance number 5 or point number 6, they're typically either into the chamber or into the screw conveyor. So it's a little bit different. These ones are typically into the front of the tunnel machine, to the front of the cutter face. What they have set on here is if they wanted to switch to semi-automatic. So in fully automatic, this wouldn't be used. This wouldn't be used. But in fully automatic, in semi-automatic, then this would be what would be injected. So you get the option to switch between fully automatic or semi-automatic. Yeah, it all becomes very obvious after a day of doing it. Not so obvious as I'm trying to talk to you now, I imagine. Different system, foam. Yeah. Sorry there. What's going on? Those are just basically covering what I said before, selection parameters, why you choose which foam. You look at the tender documents, you've got your site investigation, geotechnical investigative report, local history. Maybe people have tunneled through there before, so you might be able to get some information from them about what they did in the previous projects. TBM selection, not all TBMs are the same. They have different systems for everything, so it's important to know what they've got on their particular TBM. Spoil dumping criteria. This is where we can get our environmental advantage, hopefully. Present research and guidelines. There are no particular guidelines, which makes life much easier and more complicated in many ways, but there's typically not much. This is coming back to why choose an EPB or why choose a slurry machine. Depending on the permeability of the ground. So if you've got very, very big particles, so you have very, very high permeability, or you have extremely mixed ground conditions, you'll probably use a slurry machine because it will be impossible on an EPB machine to make a paste with only coarse grain material. You need 20% of fine material to be able to use an EPB. So that's kind of interesting. If you're going through gravel or very loose, unconsolidated soil, then you do need a slurry machine. You don't have any choice. But everywhere else, you can use an EPB. I'll just put that there if you're not so clear about what fine material means. So you need to have less than this amount of sand and silt. And then there's this graph, which is kind of universally accepted. If you take some soil and you plot the granulometric curve on this graph, you can see what's suitable for an earth pressure balance machine. And if it's outside of these bands, then you'd need a slurry machine typically. This is just the same thing when you've got a bit more information on it. A bit more information. You can read it if you want, but it's not for now. I think I've already spoken too much. What we do in the lab, we do particle size distribution, Atterberg limits if we can. We have all the information from you guys with the geotechnical investigative report, so often we don't need to do that because it's already done. So then we need to have a starting point for the concentration, the FER and FIR, or possible dosage rates of polymer. On the job site, we can check for the stability of the foam compared to our competitors, because what we often find is that our competitors sell foam that's been diluted a lot. So their price is very, very cheap, but because they're selling water. The only way you can demonstrate on a job site is to generate foam with our product and a competitor product, and you can see from that whether they've just diluted it with water or not. But what's often the case as well is that our competitors will give a fantastic foam for the trial, but then they'll supply something different. But you can also check it as the project goes on. You can see whether our competitors are cheating. And believe me, I've seen it with Sika a few times. Atterberg limits. Some more tests we do in the lab. This is in Turin, where we sponsor the Polytechnic there, and we've got our own kind of screw conveyor and pressurized thing. But not to worry too much about that. Certainly, if you send me the soil, I'll send you the information on what we're doing with the testing as well. This is just a permeability test, so you put soil in the bottom of a Perspex tube and you can see how long it takes to drain the water through. Specification guidelines, there are none. Sometimes the contracts will have something, but more often than not, they don't. This is FNARC thing that I'm sure Mr. Ann's aware of, but it doesn't really tell you anything useful. And I think that's going to do for today. I think you've heard too much already. You're bored of my voice. So for today, I've just spoken about basically ground conditioning, and even then it's just scratching the surface, I guess. But I hope you learned something.
In order to set up a presentation in Hanoi, I would like to set up a presentation, and you or Cooper maybe will come to Vietnam. So before that, I think we gotta understand at least 80% of what you said. Honestly, today I can only understand 30 to 50%. Gonna have to research your presentation and what you said a little bit more, and because in the client right now, they have no specialist speaking English. Most of them was graduated in Russia, so of course they still have the translator, but that lady hasn't in the civil engineering, hasn't graduated in civil engineering. So I would like to understand your presentation and what you said at least 70 to 80%, because at that day, if we do the presentation at the office of the client, MRB, I may have to translate for you.
No problem. I can help in any way I can. I've no problem coming to Vietnam. Happy to come. I've not been for a very, very long time because nobody's asked me.
No, we'll get you we'll get you to speak in Vietnamese.
That's going to be very difficult. I think the only Vietnamese I can remember is Camel Men.
Come on. I think we are definitely working on this, and the time frame will be sometime end February, I believe. Then we should get ourselves ready to do the presentation. And in the meanwhile, Mr. Feng can grabs as much as possible from your presentation and do more research into this.
Yeah, I'm sorry about the presentation because there's such a lot to talk about. This is only
Yep, that's right.
only ground conditioning, and I kind of rushed through that, and it's not the easiest thing to understand if you've not actually done it.
Yep.
But if you've got any questions, Mr. Punt, then just let me know.
Yeah, of course.
But I'm much happier doing it talking than writing because otherwise it just becomes a ding-dong match and we never seem to finish.
Mhm.
Yeah. Right now we are carrying about 2 items. The first one is TBM. All the products regarding to TBM like conditioner or foam or polymer. But we have the second one. It's gonna be more urgent. It is ground treatment techniques. I would like to know about a material for soil treatment. Yep.
Yeah.
And right now, the very first spec right now for Metrolite 2.1, it is the Japanese ODA. They executed the construction of Metrolite 2.1, but not the TBM. It is the package called ground treatment and infrastructure civil engineering for Metrolite 2.1 ODA Japanese. It includes, to make the soil harder. We call that ground treatment or soil treatment or soil coagulation with Z grouting and deep mixing power, and also something like electric cable or some other else for the POT station, the POT station. Yep, the very first pack before talking about the TBM. So right now, I think the most urgent is gonna be soil treatment techniques, and I may have may need your information about what kind of product we can provide and what kind of solution we can provide, like compaction grouting or something like that. If we want to join into the first spec, their first spec right here.
Are you able to get again? Like it's important to understand the geological conditions because
Yep, geological.
if you don't understand the geological conditions, I can spend 20 hours explaining to you the wrong method. I need to understand exactly what the ground conditions are. And for example, the DSM or jet grout piling, there's nothing we can supply for that. That's just cement. There's no additives that you put in jet grout or deep soil mixing. So we're out of that picture. So then we just need to talk about low viscosity, high penetration, things like micro cement and other kinds of stuff like chemical grouting, where that might be the case, but I can only understand that if you show me what the geological profile is.
Yeah,
When I say the geological profile and more specifically the permeability. Okay, for example, you can't inject through clay, but you can inject through gravel. So in clay, you have to do jet grouting or deep soil mixing. That's given. But if you've got rock or you've got granular soils, then you might have something to offer.
How about how can I say, we have a few we call that in Metrolite 3, they call that the pump pit, and they told me they have to inject into clay. And in GCP, we want to submit something not just like permeation injection. It's just not permeate. It's just kind of like compaction grouting. Like when you inject into the soil, it will explode and it will compress.
I know what you mean by compaction grouting, but that's normally done at kind of shallow depths. You normally do compaction grouting sort of less than 5 meters from the surface, where you're trying to do something. Where you've got a bridge and you've got a tarmac road attaching to the bridge, and the tarmac road always sinks because the bridge is supported properly, but the tarmac road keeps sinking down. So quite often you have to do tarmac compaction grouting before you approach the bridge to stop the tarmac it from slipping down. And compaction grouting is done also when you've got things like liquefaction. You know when you go on the beach and you bang your foot on the sand and the water comes up to the top. That's liquefaction, which is another reason you might often use compaction grouting, but it's quite rare to do that at depth. You'd normally do more sort of like permeation grouting, or you just replace it with jet grout with clay. Don't know if that helps. That's just my opinion. You might find other opinions.
Yeah. Okay, so I think I'm gonna collect specific information about our soil report. We'll get back to you later.
Splendid.
Okay, thanks, Feng.
Yep.
Since you already are in touch with Richard and Cooper, I think it's good that you just continue following up with him and give him as much information as possible for them to help you out. You know?
Because Tony promised me that the UTT budget for 2026 and 27 is going to be at least 5 times more than it is now. Because you're on board and we're looking at you to be our #1 man.
Haha. Hear that,
Forward.
Feng?
Yeah. Thank you.
Okay. Okay, Richard, thanks for your time.
Pleasure.
Been a good,
Thanks
long,
for your time.
lengthy session. Maybe I managed to grasp about 20%. He has managed to get maybe 50%.
Okay. But we've got lots of other topics as well. We need to do backfill grout and greases and oilers and things like that.
Yep.
You can do same time next week if you want.
Okay.
Yep. Thank you.
Things can set things up. Thanks, Richard. All right, Feng.
Yep.
Okay.
Thanks,
How do you
Richard.
coordinate with all
Hope to
this?
see you soon. Yep.
Yeah, have a good weekend.
Bye bye.
Thanks. Okay. Thanks, Richard. Bye.
Have a great day, Chad.